A modern logistics node operates through interconnected servers, sensors, and algorithms. Every container's movement is now driven by the constant exchange of digital signals. This satellite view of the Strait of Malacca illustrates the scale of the challenge. Because so much global trade flows through these strategic choke points, targeted cyber attacks on logistics systems can now inflict greater economic disruption than kinetic maritime incidents. The latest ENISA NIST 360 report reveals a significant gap in how these systems are protected. While the banking and telecommunications sectors have reached a high level of cybersecurity maturity, critical transport sectors, specifically rail and maritime, continue to lag behind due to limited technical resources. This integration has effectively erased the divide between the physical and the digital. To secure global trade, organizations must map exactly how an IT breach cascades into physical paralysis. In November 2024, the Termite ransomware gang breached Blue Yonder, a major supply chain technology provider, and extracted 680 gigabytes of internal communications and operational data. Large enterprises rely on centralized supply chain management software to coordinate everything from warehouse inventory to daily employee scheduling across thousands of locations. A compromise at the central software node bypasses the perimeter defenses of connected clients, moving laterally through trusted integrations. The impact is purely operational. During the Blue Yonder breach, Starbucks manually tracked payroll, while retailers faced immediate disruptions in warehouse restocking. Centralized multi-tier vendor reliance turns supply chain visibility into an exploitable blind spot. When the breach originates inside a trusted third-party application, the traditional security perimeter fails to provide a defense. This massive physical footprint belongs to the port of Nagoya. In July 2023, a Lockbit 3.0 ransomware attack forced Japan's largest port to suspend all import and export operations, immobilizing these facilities for days. The paralysis reached deep into the manufacturing sector. Toyota was forced to suspend its packaging lines for export-bound parts because the port's digital system glitch stalled the movement of components. To understand the failure, we have to look at the network architecture. Many operators rely on an air gap, a supposed separation between the administrative IT network and the operational technology. But automated OT systems require connectivity. This provides an exploitable path, allowing ransomware to jump from an office computer to the terminal controls. Without verifiable cryptographic network segmentation, a breach in the administrative IT network is likely to result in a total physical shutdown of the infrastructure. The vulnerability extends to the very edge of the network. Modern maritime navigation relies almost exclusively on unencrypted signals from global navigation satellite systems, or GPS. Jamming blocks a signal entirely. Spoofing is a complex deception, feeding the vessel counterfeit positioning data. This happened to the Stena Impero in 2019. Spoofed coordinates caused the tanker to deviate into hostile territorial waters, where it was seized. Building resilience at the edge requires an out-of-band backup for navigation, specifically low Earth orbit satellite configurations like Iridium PNT. These satellites orbit significantly closer to the Earth, delivering a signal 1,000 times stronger than traditional GPS. Because it uses cryptographic techniques to verify the signal, it is much harder for a local transmitter to mimic. Securing the physical edge requires systems that can cross-verify their location using multiple independent data sources when primary signals are denied or manipulated. We have seen how a single failure can traverse third-party software, internal OT networks, and external radio signals. A unified defense architecture technically maps NIST SP 800-161 cyber supply chain controls into the ISO 28000 physical security framework. Linking NIST SA9 to ISO Clause 8.1 integrates third-party software risks. Mapping SR3 to Clause 9.1 treats digital access with the rigor of physical entry. This unified approach ensures a software vendor's security posture is managed with the exact same severity as a physical port or warehouse. Success in this environment requires proactive intelligence. For example, Indonesia's BSSN now collaborates with Microsoft's Digital Crimes Unit to share threat data, allowing the agency to identify compromised infrastructure before a cascade begins. Trust in modern logistics begins with cybersecurity. Securing the cyber-physical supply chain is the foundation of global operational continuity.